Okay, so let's try to draw the structures of the following compounds. So you're just given names here. I always find this is a little bit easier than drawing structures from names because you're given all the pieces. So let's look at the first one, triphenyl methanol. So hopefully you remember that the structure of methanol is CH3OH. So if we have triphenyl methanol, so tri meaning three phenyl groups, so it's just going to be methanol with, instead of hydrogens, we're going to have three phenyl groups attached to our carbon. So this is going to be triphenyl methanol, putting the lone pairs there. So triphenyl methanol, actually I should circle this just so you know that this is the answer. So that's triphenyl methanol. So if we look down here, the next one is what? It is 4-chloromethyl heptan 3-ol. So we know that when we see something in brackets, we know that this is going to be branched. So this is a chain that's branched off of our main skeleton, which is heptan 3-ol. So heptan, so that means it's going to have 7 carbons. So we're going to draw 7 carbons. So 1, 2, 3, 4, 5, 6, 7. So heptan, so if we say that this is carbon 1, so it's going to be 1, 2, 3. On our third carbon, we'll put our hydroxyl group here. So it says 4-chloromethyl. So if we look at the fourth carbon, so we have 1, 2, 3, 4. So this is our fourth carbon. So chloromethyl, so it's simply going to be a methyl group with a chlorine attached to it. So this will be our final compound, fluorochloromethyl heptan 3-ol. So let me erase this garbage that's on the side. So let's look at question number 3. Question number 3, 2-cyclohexene 1-ol. So remember, this 1 indicates our hydroxyl group. So if we have cyclohexane, so cyclohexanol is going to look something like this. So we know that this is being our first carbon, has our hydroxyl group on it. So 1, 2, 3, 4, 5, 6. So we have cyclohexane 1-ol. So now we have to include in this alkene. So we have this En here, so we know we are dealing with an alkene, and it's going to come in at the 2 position. So we have our hydroxyl group at the carbon 1. So if going from carbon 2 to carbon 3, we're going to have that double bond, 2-cyclohexene 1-ol. So I'll circle that one too. So that's the final answer here. So let's move down to the last one. Let's look at the last one, which is 3-cyclopentyl hexan 3-ol. So again, hex. So that indicates that we are dealing with 6 carbons, but it's in a chain. It's not cyclohex, it's hex. So it's a straight chain. So let's draw 6 carbons. 1, 2, 3, 4, 5, 6. So 3-ol. So we know we have our hexane, so we have carbon 1, 2, 3. So we're going to have our hydroxyl group over here. So what else do we have? We have 3-cyclopentyl. So on that same third carbon, we're going to have a cyclopentyl group. So let me see if I can draw this in here to make it look neat. So we have 3-cyclopentyl. So this is our cyclopentyl group, 3-cyclopentyl. Hexane 3-ol. So this is going to be our final compound. So you can see, I always find it's a little bit easier to draw structures given the name. Oops. So hopefully that helps you with these exercises in drawing structures from names. And I hope that you'll do a lot of practice on these, because we're going to have some questions like this on our first quiz.